Hello again, conic lovers. The goal of this video is to look further into graphing hyperbolas. Before we can actually do this and use the equation to find important information, we need to remember what is most important when graphing a hyperbola. So let's take another look at what the hyperbola is. Okay, so if you slice a double cone, a hyperbola is what you see here. So it's if you cut it off so it doesn't go through the center and you go through both cones. So this is the shape of the hyperbola. And in order to graph this, you're going to need the vertex. And of course, as most conics go, you're going to need the foci. And for the hyperbola specifically, you're also going to need to figure out how fat or skinny or is it going left, right, or up, down. So we're going to need to know something about the direction and the size of the hyperbola. So we're going to need to figure out some of that stuff going on there. Okay, so with that said, let's take a look at this equation and figure out what we can find from what we see. The first thing I always find in any conic is whatever either the center or the vertex is, which comes from whatever's added or subtracted to the x and y. So in this case, since it's a hyperbola, you have a center of the hyperbola. And remember, what lies inside lies to you. So really, this would be x minus h. So we're really subtracting our h value is 3, and that goes with the x because it's attached to the x. Okay, and really this is y minus k. So in order to get a positive 1, we'd have to subtract a negative 1. So our center is 3, negative 1. Our denominators tell us important things about our hyperbola, specifically our distances from the vertices. Now, since this term is the positive term, and when I say positive, I mean it's the one not being subtracted, so this would be the negative term. This is which way our hyperbola is facing. So since this is a positive term, and this is our x term, it's going to face the x-axis. So this will be a left-right hyperbola. Okay, which means that this 9 tells us our a distance. So our a would be the square root, plus or minus, of 9, which makes our a distance plus or minus 3. Our b distance then will be important in a bit, but it's really, this is b squared, so our b distance would be plus or minus 6. Okay, the last thing we want to find is our foci. So I'll write these as points in a second, but let me just write the foci equation. So unlike an ellipse, our foci equation was a squared minus b squared. Hyperbola is the opposite, be a squared plus b squared. Okay, I remember it because it's always the opposite of the sign in standard form. So this is minus, that makes the foci plus. So in this particular case, our a squared, well, it doesn't really matter which one's which, honestly, because 9 plus 36 is the same as 36 plus 9. This makes c squared 45. So if c squared is 45, c would be plus or minus the square root of 45, which we can simplify that radical to be plus or minus, let's see, take out a square root of 9 is 3, and there'd be 5 left over. But of course we want to get a decimal so we can graph this. So our c distance written as a decimal would be plus or minus 6.71 rounded. Okay, so I'll talk about what the vertices are in points in a second, but I think it's helpful to graph when we're figuring that out. Okay, so I always start by plotting my center, which is at, let's see, 1, 2, 3, negative 1. Our vertices then are a units away from the center. Okay, a, b, and c distances are always distances from the center. So our a distance is on our x-axis, which means our vertices are 3 units away in both the positive and the negative direction. So these would be our vertices. Okay, our b distance, I'm going to plot these because they're going to help define our shape, but they're actually not going to be on the branches of the hyperbola. But let me just plot them so we know where they are when we need them. So let's see, this is 1, 2, 3, 4, 5, 6 units away. Here's our b distance, and another 6 units away in the opposite direction. 1, 2, 3, 4, 5, 6. Hopefully you're graphing this on your own paper as well while I'm counting here. Okay, so if this was an ellipse, we would connect the dots like so, and you'd have an ellipse, it'd be great. Okay, since this is a hyperbola though, our vertices tell us, where our branches are starting, and we know it's left or right, so it looks something like this, right? Now I just drew a really terrible picture, but really the reason it's terrible isn't because I'm a bad drawer, but it's because we don't know how fat or skinny it is unless we find the asymptotes of the hyperbola. So looking back at this, in order to find how fat or skinny it is, these branches are going to approach the asymptotes, but they're never going to cross it. So we need to talk about how you would find those. Okay, if you look at all the vertices I just plotted, we can create a box, a dotted line box, because it's not really on the hyperbola, but it's going to help us find the distances. So if I create a box out of these vertices, it looks something like this. Okay, and then the asymptotes are just lines that go through the corners of the box. So one of my asymptotes would be, if I could draw a straight line, it would be here, and the other one would be going through the center through those vertices there. And now I can plot my branches because it's going to get close to those lines, but it will never touch those lines. So I know that this is a little bit of a fatter hyperbola, like that. Okay, now the reason that this works is because the A and B distances define the shape of the hyperbola. Okay, just like A and B defines the shape of the ellipse, how either narrow or stretched out or whatever it may be, that's what A and B tells an ellipse. A and B tells me the same thing about the hyperbola. Okay, the ratio tells me, is this going to be, really wide or really narrow? It's just a little bit harder to see than in the ellipse. So with that said, the one thing I didn't plot is the foci. So starting at the center, the foci would be plus or minus 6 units, 6.71 units away from the center. So the center is at 3. It's on the same axis as the vertices are. So I'd move left and right 6.71 units. So let's see, 1, 2, 3, 4, 5, 6. And we want a little bit more than 6, so it's going to be about here. Then we're going to repeat the same thing going the opposite direction. So we start at the center, we're going to move 1, 2, 3, 4, 5, 6. Oh, I'm running out of room, but that's okay. It's going to be a little bit more than 6, so it's going to be about right there. Okay, and the foci do help define our shape. Now, we don't structure our hyperbola because of the foci, but if you were constructing one, the foci would be very important, so we do have to plot those. Okay, the last question would be, if I'm asking you to find the information, of course, you should tell me what these points are. So this would be, let's see, I can count x is 0, y is -1. You can tell me what all these points are after you've graphed them. I think it's better to get a visual first. So this would be 6, -1. But the other thing I might ask you is, what are the equations of the asymptotes? And I think it's more intuitive to go ahead and graph them and then figure out the asymptotes, because we all know that these are lines. And we know all lines have to be of the form, let's get a different color here. All lines have to be of the form y equals mx plus b. So if we can find our slope and our y-intercept, we can find the equations of the asymptotes. So in order to find slope, I need to pick 2 points on the asymptote, and you can either count rise over run or whatever you want to do. So maybe I'll pick this point here. So our asymptote, this one at least, goes through this point and this point here. Okay, so let's figure out what those points are. This one would be 0 on the x, and it moves up 1, 2, 3, 4, 5. Okay, that's the corner of one of my boxes. And then this point here is the center, so that's easy to find. The center we said was 3, -1. So if I want to go from this point to this point, how many would I have to rise? If I'm starting at -1 going to 5, I would have to rise 6 units. So our slope will be 6 over whatever our run is. Okay, to go from our x value, which is 3, to 0, we'd have to run 3 units. But really moving in the negative direction. So one of these has to be negative. So our slope would be -6/3 x, and we'll find b in a second, which makes this slope -2x. And we know it's negative because it's pointing in the negative direction. Okay, y-intercept then, well, luckily our box is on the y-intercept. So in this case, the y-intercept is at, let's see, 1, 2, 3, 4, 5. So our b would be +5. Okay, if we look at our other line, if you think about it, our slope is really defined by our a distance and by our b distance. So notice our b was 6, our a was 3, and our slope was 6/3. So this must have been b over a. Interesting, right? In our other line, if you take a look at 2 points, it should probably mirror the same pattern. So let's see if it does. Okay, we need to figure out our slope and our y-intercept. So our slope in this case, let's see, to go from, I think this point is 1, 2, 3, 4, 5, 6, and we had to go up 5. So if we mirror y equals mx plus b, we need our rise over run. To go from this point to this point, our y would be changing 6, our x would be changing 1, 2, 3. So in this case, it's positive 6/3 x, which makes sense because it should have the same slope as our other asymptote, which is also, again, defined by our a and b distances. So again, this is b over a. You don't need to memorize that equation b over a, but it's good to know where it comes from. As long as you can find the equation of a line, though, you don't need to memorize anything else, which is fantastic. Our y-intercept in this case would be this point down here. Okay, so this asymptote crosses at, let's see, this is negative 1, 2, 3, 4, 5, 6, 7. So it would be 6/3 x minus 7, which our final answer for this asymptote would be 2x minus 7. So if I asked you to find the asymptotes, I don't expect you to memorize any equations or anything like that. I expect that you could be able to draw them, and we all know how to write the equations of lines, so you could find the equations that way. So now we know everything about the hyperbola. We know how fat or skinny it is. We know where it's located, and you should be able to graph these all day and night. So good luck with that, and come to class with questions. Bye-bye.